Awesome. Then we are ready to start. I would like to thank everyone here for coming. I would also like to thank everyone coming to us on stream today or watching this in recording. We are very happy to see you guys being interested in IPFS and Filecoin. And today's session would be the introduction to IPFS and Filecoin, and we will talk about how they shape the future of Web3. We are on Start Summit and Hack today, and looking forward to the session. So first of all, thank you a lot for coming. I'm looking forward to tell you a bit more about who we are, how we work, and what is the future of Web3. So first of all, I am a startup operator at Protocol Labs. Protocol Labs is an open source research and development lab, which is building protocols, tools, services to improve the internet. One of our core of fundamental technologies and protocols which we are developing includes IPFS, Interplanetary Filesystem, which is a peer-to-peer protocol that makes web upgradable, resilient, and more open. This allows a peer-to-peer communication and exchange of data, and therefore you have all the flexibility and resilience of the peer-to-peer communication at the scale of a high-level production-ready data exchange like cloud nowadays. Our protocol is Filecoin, which is decentralized storage network to store most humanity important information. This allows us to upgrade the IPFS as a peer-to-peer network and also ensure that your files are being stored on the network, that they are verifiably stored, and they will be there for as long as you need. At the same time, we incentivize the storage providers to store the data for you. I'll touch that further in the presentation, but this is how we ensure that both parties of storage providers and people using for storage are all happy using our technology, and it's resilient and long-term upgradable and verifiable. So what will be our agenda for today? First of all, I will go through the core concepts of IPFS and Filecoin. Then we will talk a bit about tools for Web3, the possibilities of Web3, and then I will share with you some further opportunities to learn about IPFS, Filecoin, foundations, protocol labs, and then we'll have a short discussion and Q&A with you. Please bear with me for the core concept of IPFS and Filecoin. We will dive a little bit into the technical specialties, but this, I believe, is very core to understanding how it works and understanding that all of the topics which I say as resiliency, stability, verifiability are in the core of protocols, and we are not just using this as a marketing or saying we can do so, but we cannot. It's all fundamentally inbuilt in the protocols, which allows us also to say that we are the future of Web3 storage. So speaking about internet, I mean, you all are familiar with it, you all are using it. And generally, the internet is essentially only wires and networks around us. Then there is a Web3, Web 0, and Web 1. Web 1, Web 2, and Web 3. Web 1 was a long time ago. We had only read-only websites with static information. No one could interact with them. We passed that stage where right now, or most of us are in Web 2, where we can read and write. So basically, there is a website from which you can retrieve an information, and then you can write an information. Most of you know LinkedIn, Facebook, anything where you can interact is a Web 2 essentially. I will not go in too much detail about what Web 3 is, but let's suffice that it's the next evolution of web. It makes the web read, write, and trust, where trust being the operative thing there, and it's achieved through verifiability of all what you interact with on the web, and it's being supported with a whole bunch of underlying primitive technology that builds up to it together. Speaking about primitives for the Web3 stack, verifiable data is essential to truly distribute the system. One of the big pieces of the Web3 stack is how do we store data in a way that it aligns with the mission today, that the data has to be distributed, verifiable, censorship resistant, and internet has to be owned by people. And that's what is the best of the Web3 at the moment. But how we can reach so? You see the whole stack. I mean, there are a lot of functionalities in it. And that's the beauty of Web3, where there is no single provider that provides you everything you need, but rather there is a community sourced or community engineered protocols, which each of those are to do one specific function to it, but at the same time, they all are open and collaborative so that everyone have the opportunity to join the network and work together to reach the better goal together. So right now, believe me or not, we are in transition from Web 2 to Web 3. All of our data right now is centralized, and generally data, information, and knowledge, it's still the most important asset in our connected area. But at the same time, we barely have the control of it. We barely have the access to it, to our own data. And in the Web 2 model, decentralization, there are only a few companies offering you the storage or generally offering you the services right now, such as Microsoft, Google, Apple, Amazon. And if any of those fail, basically you lose access both to your information, to your data, to the technology. So any centralized solution is prone to fail, as there becomes a single point of failure, which if something breaks, you will not have access to it. Therefore, it also does not allow you to have long-term vision of your project without specific service or solution, because then you immediately lose all your previous data, all your previous knowledge, and the upgradability. You have to rely on a certain solution to make sure your projects are working. But instead of building everything in a centralized manner, relying on a single provider, on a single solution, we believe that the decentralization is the first step and the future of Web3, where you can reduce the reliance on a centralized solution, on a centralized protocol. And the more and more you become decentralized and then distributed, meaning that you can also reshare the most of the functionalities on multiple devices, on multiple servers, and make them interconnected in a peer-to-peer manner. That's where a naturally distributed and resilient system will appear. So we all know that there were so major flaws in the centralized solution, where there are single points of failure, there are data leaks, the database is thrown out, and then final users being exposed and not sure how to continue their projects, how to work. And we aim for the distributed internet, where the users have the power inside their service. It has to be censorship resistant, it has to be private, it has to be self-verifying, and there should be no silos of data. So in the next 30 minutes, I will give you an outlook on how we build it at Protocol Labs, what is IPFS, which is a peer-to-peer hypermedia protocol for content addressing, and I will tell you a bit more about Filecoin, which is the world's largest decentralized storage network we are working towards. And those are important building blocks to build the Web3. And believe me or not, I will prove you that files and folders, they might sound boring, but they are definitely not. So let's start with the files and folders. So IPFS, what it is. IPFS is an interplanetary file system, and file system is exactly files and folders. What interplanetary means to us? Because we conceived as a way to upgrade the web still should work when we stretch across the planets. That's our vision. Imagine you're working on Earth, you're communicating with someone on Mars, and the problem is that you will rely on the speed of transmission between the data from Earth to Mars, which will take around an hour to do one single call, which makes no sense. If the data is centralized, you will have to call the central unit on the Earth every time you want to do any operation. However, if you already have your content being available on Mars from someone else, you can just fetch it from Mars, and then you don't have any need to actually communicate with Earth at all. And that's what exactly distributed and decentralized network means. So we are also focusing on no single server and resilient offline first. Therefore, all the data is not being fully always available on public, but there is a peer or node in the network which can send you back your information whenever you need it. So how do we do so? The beauty of our technology is that IPFS addresses content by what it is instead of where it is. I believe you're all familiar with searching your files on computers or searching something on the internet like an image. What you need is basically a path to the file. So you tell, okay, go to the disk D, go to a certain folder, there is my object, I can open it. The same you do with Web2. You have an IP address, you go to a certain domain, you go to the URL link where the file is located, and you obtain it. Similar you do in cloud services where you retrieve a file from the cloud through a certain URL. What we do instead, we replace a folder or a file with a content ID. So once an object is coming to the IPFS network, before we store it, we actually assign it a content identifier, which is a unique description of what the object itself is. And it's provided by a cryptographic function, meaning that all the time you want to create a content ID, it will be unique to a certain file. And if you do this fingerprint from a different computers, but to the same object, it will remain the same. That means that any object which is uploaded have a unique identifier, but at the same time, it will be the same across all the network if the object is exactly the same. So how does that help? The same content becomes the same CID. And the content ID could be reproduced at any time from the original content. And this allows us to verify which objects have been transferred across the internet. Moreover, the copies of the content become the verification of the object by itself as well. And this allows us to do the verifiable Web3 by design. We don't only work with objects as a final solution, we also can do the same for the folders. And folders is essentially a special kind of a file which lists all other files that's inside. So the same way you can do a CID for an object, and believe me, object could be anything from a file, video, any element of your computer system which has an object, you can create a CID out of it. The same you can do with a folder. You can create a cryptographic function out of it, and basically you have a CID, and CID is just a 30-letter, 30-element line which describes your object uniquely. And it uses SHA 256 to describe the objects. And what does it mean for us? What's the beauty of it? Here's an example of a network where there are multiple objects, there are multiple folders, and I will explain to you how the communication is happening. You see a small fingerprint in the elements. That's basically a CID. We have a root CID, which describes the first and main folder. Inside the first folder, we have two more folders, which were created by different users. And these folders contained 3 elements on the left side and 1 element on the right side. And even though they were pointing all to the different objects, the final images have their unique CIDs. So imagine if a new user comes and wants to create a file or a folder containing some of those images, but at the same time, he wants to do it in a resilient way. Basically, the network already have the data, and the data is also being discovered by the graph structures you see, where each node is content addressed and connected to other nodes. So a new user comes, he creates a new folder, he uploads or uses the images which already exist, and basically he creates a folder which points to the CIDs. But the beauty of the whole CID system is that objects were already existing, they are in the web, the CID pointers will point to the existing data on the network, and user may not even need to upload it, it will be already available for them. This allows us to duplicate the internet and basically reduce the huge amount of copy stored on the internet, memes, images, photos. If they are the same, we'll have the same pointer, and we don't need to store like thousands of the same files. We can store 5 and just send them from the peers which are the closest to you. So deduplicating the internet is also a point which Web3 allows us to do so. And at the same time, we can verify the content which you will receive, just because once you download the object, you can have a CID of it, and if it matches with what you requested, then it's the object you wanted. But there is no man in the middle attacks where someone tries to substitute the content with something else, try to hijack you, try to scam you. There is no such opportunity in Web3 because everything is verifiable from the design. So this is how it works on a single computer or on a single folder. Let's talk about how it works all together. So then on each and every computer which is connected to our network, we have a peer system where everyone can store data, exchange data in a peer-to-peer manner. And the beauty of it is that no one needs to store all the copies of all the data at any point of time. Essentially, peers contain a really small part of the information. They store multiple files, and we just create a collection of all of the peers and all what they store, so we can discover an objects in the internet. Basically, the two requirements that we put on the nodes in the IPFS is that they must be discoverable and they must be routable or reachable, meaning that from any node in the network, we should be able to reach any other node through a number of connections, so that content which is stored on this node will be accessible for everyone. That's where distributed hash tables come in place. Basically, distributed hash table is maintained by multiple peers, only a small number of rows and stored in each peer. And it's a table which contains all the information which those peers have. Basically, it's a list of I have this, and this is the key of this object. Basically, a CID and where it could be discovered, another CID or content identifier of the peer himself. This is a simple two-column table which basically stores keys and values, and that's all what we need to discover. What is the function of every peer then? Once we request, okay, I want a certain CID from our network, it will first call the closest peer asking, hey, do you have this content? If it's not, it will request to the further peers asking, who of you have this content? And you don't need to go through all of the nodes. That will be super redundant and basically super slow. Instead, we call these distributed hash tables, and each node can check whether in its distributed hash table, which is connected to multiple nodes, if there is any content like this. If there is no, it pings another node not in its surrounding. And moreover, we just not go through each and every distributed hash table, as you may imagine. We also know that CIDs are distributed across the internet in a certain manner that in the network. Therefore, it's all smart and it's all continuing to automatically update the network. So at any point of time, the objects and files are being discovered in our system. That was a short deep dive into how the tech stack works. I hope it was clear to the level that we can continue further. But now I will show you the other side of it, the user side of it, or basically how the IPFS use works in the wild. So as far as what I was explaining to you, there might be a node with the files in it, and you may own the node. So how does the network, where the network comes from? If there is no nodes, there is no retrievability. So who would want to run a node on a peer-to-peer network to store the data for you and why? That's a fair question. No one will want to store a data for you for nothing. You have to incentivize them somehow. But first of all, you can run your own node and you can retrieve from your own node at any point on the internet the data. You may also want to run a network of nodes, which will be a little bit costly. You will need to set up an infrastructure, but basically you have a network of nodes, then you can retrieve it and at a good level of, at a good speed and at a good resilience from all across the internet. You can also pay a pinning service to pin your content on their nodes, such as there's a lot of solutions existing, Pinata, Temporal, and Fur, and more. And then you just hope that your content becomes popular enough that other nodes will pin it, so you will have the fast and available data for yourself. Does that sound to you, as we are in decentralized and reliable Web3, that you have to rely on someone else to have a goodwill and trustworthiness? Not to me. And that's where the Filecoin comes into the place. Filecoin incentivizes persistent and verifiable storage, which is designed for Web3. It uses the same CID hash from IPFS and generally a standard of the web3. It provides a verifiable storage via cryptographic proofs, and it's self-managed by an open market to store the deals. And let me tell you a bit more how it works. So Filecoin uses the same process as the IPFS to create a content ID of any object you upload to it. But in addition to that, it allows you to secure the deals which ensure that your content on the IPFS network will not be deleted, and that a storage provider commits to store your file on the network and get a reward for that. He will get a reward from blockchain itself, so that while he stores the files of other users, and our providers provide a huge amount of data, they're storage providers with a huge disk spaces, basically storage networks, and they commit to our network and they store the file for you in order to secure deals and get a Filecoin as a reward. So you put a file on the network, it can automatically do a deal for you if you run storage helpers. You can also do it by yourself, all self-managed. But basically, you will have a Filecoin deal which contains information about your object, essentially CID, and it tells all the network that this CID should not be deleted because it contains valuable information from the Filecoin. What you can do further, you can either repeat the deals over the time so that your file persists till the moment you want it to have. We don't promise you that we provide you a permanent storage. Fairly, no one can really do a permanent storage because we don't know how our web will look in 10 years or so. But what we allow you to continuously upgrade the deal or continuously renew the deal so that it could be all the time available while you need it. You can also run parallel deals for the same object at the same time. That's where we receive the resilience of the internet. If you store it only on one server, it's again the centralized system, it's prone to failures. Most of the content which is stored on Filecoin is duplicated at least 5 times, so that regardless if one node goes away or there is the problems with the storage provider or anything happens in the web, your data is basically safe. We replicate the data at least 5 times. You can do it even more if you believe that your data is very valuable and has to be backed up more times. That's totally possible. But basically, that's how we ensure that your content is available all the time, regardless of any situation. Multiple nodes at the same time store your content, and the closest to you will retrieve it to you once you have interest to receive it. You can also do it in cloud. And the beauty of Filecoin is that it can match with any data storage in the internet. You want to back up your cloud solution, you can do so with a Filecoin. You can even continue from purely cloud solution to purely Filecoin solution with a matter of, I believe, two lines of code change. It's that simple. It's just connecting to the network and providing the API keys. So we have to know who is uploading the data. And basically, that's how the whole internet works in Web3. So once again, to repeat, for the permanence, any storage deal can be renewed an infinite amount of times for anyone and by anyone or for anything. It could be done by smart contract. We're developing a virtual machine right now. We'll be operating smart contracts. Right now, it's also done by our storage helpers. There are multiple projects which allow you to do that easy without code and basically upgrade your website or your solution from day one. We also store it for redundancy once again. So you can create an infinite copies of your same storage deal. Therefore, the thousands of providers in the network will ensure that your copy is stored, which also, and interestingly, drives the price of the storage down for everyone. The more files we store, the more the miners receive as a reward from our blockchain. And the more they store, the more the Filecoin they receive, the more they are incentivized to store the data cheaply, because there is a market and a competition for storing the deals, and they eager to store the data at the cheaper prices so that they receive the deal and receive the reward. And that's where IPFS really loves Filecoin. They are perfect component to each other. IPFS is here for fast, flexible retrieval. We provide you not only the IPFS nodes for which you can retrieve the data, There are also gateways, local nodes, and even browsers that natively work with IPFS at the moment. If you're familiar with a Brave browser, it has an integration to IPFS. It can retrieve the data from the web automatically. The same way you put a URL link, you can put a CID and it will show you the content which is there. We are right now working with upgrading to Chromium and to Firefox. So these browsers quite soon will also be, or relatively soon will be also native for IPFS and Filecoin to showcase you the data. And Filecoin in this IPFS Filecoin love is for persistence and verifiability of the data, where it ensures that your data is there in the network for you to get the access of it. That was a short deep dive. I hope you are still with me today here. And the further on, we will talk about the tools for Web3, or basically how to build your applications on Web3, or how to upgrade your applications from the existing ones to the Web3 as well. So any Web3 architecture with a decentralization in every layer is basically a front end. It could be a traditional Web2 front end, which the whole internet is with right now. It could be also a Web3 front end. It could be an NFT, a dApp, or a decentralized website. We also provide solutions for that, and I will speak about it in a second. There's also should be a logic, which could be a standard application logic, or it could be any smart contract, Ethereum network, or any other network, basically providing you the logic or the functionality behind your front end. There's also a storage helper, which supports you on storing your data, retrieving your data, and ensuring that the database is all linked together so that logic has something to operate with. And basically below there comes Filecoin and IPFS nodes, which is the storage of Web3 right now. And we're looking to expand even further to Web2, Web3, making the internet upgradable and resilient. One small comment about storage helpers. Basically, they allow you to integrate, work easily with IPFS and Filecoin without setting up your own nodes. And they are there to support you with your data without even sometimes a deep tech knowledge, but rather just an interest that I want to have the control of my own data. And that's where the storage comes from. First of all, and the most simple one is the NFT.storage. How many of you, by the way, are familiar with the NFTs? Awesome. So basically, most of the NFTs over the internet is stored with IPFS and Filecoin. All the OpenSea, Rarible, any project basically backs up their data with us. And there is a lot of sense in that. If you want to store an NFT, basically you have to store the asset, the image or something like this in the internet. And storing data on the network is very, very expensive. I checked, I think last month or 2 months ago, storing 1 megabyte of data on Ethereum network costed you $55,000. And that's just not scalable. And it's the same for almost any network. Storing data on-chain is very, very costly. What you can do instead, and basically what everyone is doing instead, they're creating a CID of the object they want to store. And in the on-chain, they store only CID, which is a 30-unit data. It's very light, it's just 30 symbols. And then they point to the data on-chain, off-chain on our network, basically on the storage providers in the IPFS network. So whenever someone wants to see their NFT, they receive it from the IPFS network. And basically Filecoin ensures that your NFTs, which are not changeable once they minted, they have the content through their lifetime, not when the network fails, but it really is persistent for the whole lifetime because you have the pointer to the content, not to the location where it's stored. In the early days of the NFTs, it was happening that people were using traditional web links to store their NFTs. And then there were rug pulls where basically unlawful providers were changing the images of your NFTs. There was a quite cool topic of rug pull where a person minted a whole bunch of NFTs with art and then changed all of them after he sold it to the carpet images. And that's because it was pointing to the address where it's located, not to the object itself. And basically that's where Web3 ensures that the content you wanted to receive, you will receive. Otherwise, there's a flaw in the design. You don't need to trust someone in order to receive the data you want. Going from the NFT storage, which is, by the way, it's very simple to interact with. It's basically 2 lines of code to change from any storage provider you have right now to resilient IPFS solution. Moreover, you can also do that in parallel. You can maybe store it on your backend device for the speed and ensuring the quality at any point of time, and you can back it up by the IPFS and Filecoin. We love to upgrade the internet in any manner, so whenever you need a solution where you want to store your data, it could be plugged into one of our solutions. So coming from the NFTs, the simplest topic, there's the web3.storage, which is designed not only for NFTs, but basically whatever you want to store on the web is possible for you through the Web3 storage. It's designed for interacting with Filecoin and IPFS. It has a very familiar and simple interface. I really like the interface designs, by the way, of IPFS and Filecoin. And it will create a CID of any object you want to store and then provide it to the IPFS network and pin all the data so that you don't have to worry if it will be available for you later on or not. Both of the solutions which I showed you as well provide a 1 terabyte of free storage. And even if you exceed the limit, it's possible to extend the data for free. Or if you will do the deals, you want to have the control of the data flow on your own. Our estimations, or not the estimations, our calculations right now is that it is 100 times cheaper to store the data with us than with cloud providers like Amazon, Google, etc. So it's at least 100 times cheaper. And if it's all dependent on the Filecoin price network, where if the Filecoin price rises, actually for storage, it's good because then the cost of storage will drop even lower. Because storage providers are incentivized to store your data, not because you pay them, but because they receive the Filecoin reward as a reward for ensuring that they store your data. Next item, or the next usable tool for you, is Fleek hosting. Basically, Fleek is a fully powered IPFS Filecoin solution, which also allows you to build websites and web apps in the open web. It works very simple. It connects to your GitHub repository of your code. You can add your build settings and you can deploy your site on IPFS and Filecoin, making sure that you are not dependent on any storage provider or domain provider. Your website is basically available as an object on the IPFS network. It works with most modern frameworks like Docker, Gatsby, React, and many more. And it just allows you to upgrade your website within also a minute. It's really integrated to everything. If you want to upgrade your internet and have a developer control of ways to connect to IPFS, Filecoin, and all other protocols like libp2p, there's also a PowerGate solution, which basically bridges this all with the communication layers, and you have the full control of the Web3 stack across all the technology, not only for storing, but actually ensuring that all your elements of your solution are resilient to the future. So these are the core tools which anyone can use in Web3. They are completely free. We are working as an open protocol, so all our protocols are first open source. Secondly, they are available to you on GitHub, and we are not only happy that you use it, but we are supporting you on the way to build it better. It's open for contributions, anyone can develop it, and it's a lively network of at least 15K developers right now who are contributing to parts of our protocols. So what are the possibilities of Web3? This is a really outdated list of who is using IPFS and Filecoin. I think it was gathered like 3 or 4 months ago. But basically here you see at least the biggest names who are using our protocol for different points. And we're being integrated to many, many tools for storing the data, becoming not only the storage provider of Web3, but also really gathering the cloud data from the Web2 and ensuring that it's available and persistent. Some of the names might be familiar to you. Some of them are purely Web3, from new versions of YouTube, music exchange, to financial solutions, other blockchains. So we are integrated in the network at its most. And the beauty of it that the network is continuously growing. We are onboarding a huge amount of startups, protocols in our network. We are happy to support all the developers. From day one, we are also working as an investor, supporting the startups, not only to build on our technology, but we also invest into the ecosystem from pre-seed from the developer, grant money, like on the hackathon, to I think Series D right now. And we have quite a good portfolio of growing companies on the internet. At the same time, we are looking into the opportunities of scalable storage, and we're looking for the next 1 billion NFTs being stored on our network, if it's not already. And we are also developing the solutions for the metaverse. Some of the few solutions which are possible to build on our technology are tickets, game assets, music, video storage, AR, VR assets, documentation, POAPs. All this is either already somehow implemented, or there are many more projects coming to build in this direction with our tools as a storage. So once again, those are only a few examples of IPFS and who uses IPFS and Filecoin. These are the ones which I personally really love, from open data set of New York right now is being stored on the IPFS, to the Starling lab, to the Internet Archive, which stores the most important humanity data. Starling lab is basically a lab of a Shaw Foundation, which preserves the information about the people from the Holocaust, to keep the information verifiable. And even if you have the most world sensitive data, we still can ensure that it's immutable and resilient across the time. There is also applications like Audios, which is a new format of not a new format, but a new audio streaming solution. And maybe you're familiar with an OpenSea, which is basically the largest NFT platform. To sum it up, the Web3 is a decentralized web, which is powered by blockchain and by linked data. We're not building one single solution to rule them all, and we don't believe it's actually possible in Web3. Rather, we focus on the protocols, on open source protocols, which ensure the internet quality and is a buildable and upgradable block to everyone else to build a better internet. Thank you a lot. That was a short introduction to IPFS and Filecoin. I was happy to give it to you. My name is Konstantin. And if you have any questions, we are more than happy to answer them right now, as we still have a little bit of time. I would also like to thank everyone on the stream. That was a pleasure to talk with you. I think we are looking forward to seeing you around. Check our GitHub, commit to us, visit our websites. We are looking forward to build the technology together with you. Thank you, everyone, and that was a pleasure.